Sixth grade, back in 3.4, and finding the greatest common factor. Okay, this is also, if you see, GCF. That stands for greatest common factor. Okay? Now, what that means, factors are the numbers or the ingredients that make a multiple. Just like elements that make a compound in science, factors are numbers that make multiples. So we're trying to find the biggest number. Hello, look at me and listen. We're trying to find the biggest number that goes into both numbers. That's called the greatest common factor. The biggest number that goes into all of our numbers that we're given. So, there's two ways to do this. Guardian, look at me. The two ways to do this. One is to think of the factors, or list the factors, and then find the biggest one. Okay? So, if we start with 12 and 60, how would we list all the factors? How do we list all the factors? Remember when we talked about this? We want to make sure that we get all the factors. So what numbers can you use to multiply and make 12? To make 12 first. Jared? 1 times 12. 2 times. 2 times what? Makes 12. 2 times 6. How about 3 times 4? Any other ways? Any others? Any others? No. That's it, right? Because we started with 1 times the number, and then listed all the ones in between, right? Oh, now we got to list all the factors of 60. Carson, 1 in 60. That's where we need to start. 2. Then we go up so that we don't miss any. 2 and 30. 3. Does 3 go into 60? Yeah. 3 and 20. 4.
Yeah. 4.
4. 60 divided by 4?
4. Yes.
4 goes into 6 once. Remainder 2. Yep, 4 and 15, right? 4 and 15. 5 and 5 times 10 is 50. 5 times 12. And 6 times 10. 7, 8, 9, 10. That's it, right?
Yeah.
Is there a number that's common in both lists? 12.
And 2.
So 12 is the greatest common factor. Okay? Now, class, listen. Are there other common factors?
Yeah.
Yeah. We have
1, 2, 6.
now 1. Listen. Don't start with 1. 1 will be a factor of every number. Right? But the 2s, the 3s, the 4s, the 6s. But we're looking for the greatest common factor. Okay? Now, class,
Yeah.
there's another way. Okay? And this way I think you're going to find is a little easier. Right? This way is using our factor tree. So, when we factor the numbers and find the prime factorization, we find that we can make 12 by using 2 squared times 3. Okay? And you can make 60 by using 2 times 5 times 2 times 3. So we're finding all the prime factors. Then, the common factors are the ones that are in both numbers. So there's 1 2 in both numbers. There's another 2 in both numbers. So 2 squared is a common factor, isn't it? What is 2 squared? 4. So 4 is a common factor, isn't it?
Yeah.
Yep. Is 3 a common factor? Yes. So 4 times 3. Is 5 a common factor?
No.
Does 5 go into 12?
No.
No. So we found our common factor. 4 times 3. Right? By multiplying the common factors, you get the greatest common factor. By multiplying all the common factors, you get the greatest common factors. Okay? So, 2, 2, and 3. Those are all the common factors, all the prime common factors that are in both numbers. And that was a lot simpler than making the list of 60 and making the list of 12 and then finding the greatest common factor. Now, you can do that. There's nothing wrong with that. But this way is a little easier. Okay? Let's go through some more examples. Go back to your book. Let's do number 8. One of the things you may be able to do is just think of the factors. When there are just a few factors for each number, then you don't have to go through the process of listing them all and finding it. Okay? You can just think, what numbers go into both? Well, 2, 4. Any others? But 1 is never going to be the greatest common factor. Well, no, I shouldn't say that. 1 could be the greatest common factor, couldn't it? Yep. If you have both prime numbers, or if one of them is prime and it doesn't go into the other number, that's a good point, Nate. One might be the greatest common factor then. Yep. But in this case, we've already thought of bigger ones. Is 5? 5 goes into 20, but 5 doesn't go into 16. 6, 7, 8, 9, 10. So 4 is the greatest common factor. So sometimes it's that simple. It's just to think of the common factors. How about number 10? We have 50 and 75. I don't want to list all the factors of 50. So let's use the other method. We're going to multiply the common factors. Okay? So, factor 50. 5 and 10 makes 50. 5 and 2 makes 10. And then 75. How about 3 times 25? We know that 3 times 25, right?
Yep.
And then 5 times 5. Now, multiply the common factors. What factors are in both?
5.
5 times 5, right?
I want to get this. Because you're going to do 25.
Yep, that's what we did. 25 times 2 makes 50. 25 times 3 makes 75, so 25 is the greatest common factor. Okay? These are the common factors that are in both. So multiply one set. Just 5 times 5 to get the greatest common factor. Copy this one down. Number 12. Number 12. Copy this one down. You might be able to, but I don't think that's going to work for, well, maybe it will work for this one. 12, 50, and 60. Now, you could list all the factors of those, but this way is going to be faster, trust me. We factor 12. We know that's 2 times 6 and 2 times 3. That's the prime factors. Factor 50. 2 times 25 and 5 times 5. And factor 60. 3 times 20. 5 times 4. 2 times 2. Now, we have to find the numbers that are in all three. There's a 2 in every one, right? In the other common factors. There's another 2 in this one, but not in this one. There's no 5s. 5 doesn't go into 12. So what is the greatest common factor? 2. 2 is the greatest common factor. There are no other common factors. There's a 3 in both of these, but not in the 50. So that's all we have. You see how simple this is? All right. Your assignment is 8 through 32. Evens. Yep. But skip the sections that we've already done.